All right, this is 5-7, day 1, triangles and coordinate proofs. Today and tomorrow's lessons are more conceptual. All right, so really have to keep that in mind. So we're working on coordinate proofs, and it says up here in the corner, you use use figures in the coordinate plane and algebra to prove geometric concepts. So that is why we do these and how we use them. The first step in the coordinate proof is placing the figure on the coordinate plane. All right, so we have some steps. So let's place these triangles on the coordinate plane without actual real numbers. So yeah, more conceptual than anything else. All right, so we're going to position and label right triangle ABC with legs AC side AC and side AB, so that side AC is 2A units long. Okay, 2A units long for AC, and AB is 2B units long. Okay, what are A and B? We don't know. Again, conceptual. All right, so gotta think in concepts and not concrete. Okay, so positioning the triangle. So step 1, we're going to position this triangle in the first quadrant. So it's going to be all up here. Placing the right angle of the triangle as angle A. Okay, at the origin. Okay, at 0, 0. So we're going to place angle A here at the origin. Okay, so that's angle A. At the origin, we'll allow the two legs to be along the x and the y axis to make our life a little easier. Okay, step 2, determine the coordinates. All right, so because C is on the y-axis, all right, C is going to be on the y-axis, its x-coordinate is 0. Okay, its y-coordinate, all right, is 2A units long, because the leg is 2A units long. Okay, so we're going to go from A up the y-axis just a bit. How far? As far as you want, as long as you stay on the graph. This is C. Okay. Remember, A is at the origin, so it's 0, 0. Okay, C. All right, so C's x is 0, because we didn't go left or right, and it is 2A. 2A. All right. Now, because B, okay, is on the x-axis here, the y-coordinate this time is 0, because it doesn't go up or down. And the x-coordinate is what? 2B. All right, so where on the x-axis? Somewhere. As long as it's on the x-axis, it doesn't have to equal it, because it doesn't say A and B equal each other, so they can be different lengths. All right, so this is B. All right, and its coordinates, well, we know our y is 0, and our x, well, that's 2B. Why do we pick A and B? Because that's part of the points. I don't know. I didn't make it. All right, so we have them. All right, I know this is it's very conceptual. It's very conceptual. We're going to take our ruler and we're going to draw a right triangle. Okay, drawing our right triangle. There we go. All right, so we drew our right triangle, our conception of a right triangle anyway. All right, so put it down there. Is it exact? No, and your triangle may look a little different as long as C is on the y-axis and these are your coordinates, and as long as B is on the x-axis and these are your coordinates. I mean, it could be here or here, or like, you know, the size of the actual triangle isn't as important as knowing the coordinates, okay? So yours might look a little different, and that's fine. Now let's identify some missing coordinates. Okay. Conceptual. All right. So we are going to name the missing coordinates of the isosceles, okay, isosceles triangle, RST. So that means we know that this side and this side are the exact same length, all right? And then that means these angles are the same length, and we know this is the same length, all right? So we know some things, all right? And it also tells us S is 0 because it doesn't go right or left, so X, of course, is 0, and then it's B units high. That's what that says. That's where S is. Okay, so it wants us to find the y coordinate of R and T. Well, your y coordinate tells you how far up or down from the x-axis it goes. Well, the R coordinate is on the x-axis for R. So, did we go up? Nope. Did we go down? Nope. We made no movement. So that is 0, minus 2a. Okay, same over here, okay? T. All right, T neither moved up nor down from my x-axis, and we aren't moving any units up, aren't moving any units down. Your y is 0. So the base of the triangle, okay, it's the base, because remember, vertex angle across from vertex angle is a base, okay? The base of the triangle is positioned on the x-axis. Yep, see that. So the y-coordinates of R is, well, we just proved it's 0. And the y-coordinates of T is also 0 because it's literally on your x-axis. It's not above or below it. All right, so we're going to use the properties of triangle RST. So because triangle RST is isosceles, RS, side RS, is congruent, okay, to side TS, okay, and so therefore angle SRT is congruent to STR by the, well, it's an isosceles triangle, so it is by the isosceles triangle theorem. Okay, so it wants us to draw an auxiliary line. Remember the auxiliary line, it goes from your vertex angle straight across to the base, and it becomes your midpoint. Okay, the midpoint happens to be at the origin. All right, and it wants us to label that intersection point Q. Okay, so we have a midpoint Q here because SQ and RT coincide with your axis lines. SQ is perpendicular to ST, okay? And so if they are perpendicular, that makes these right triangles, all right? And we already know that this angle and this angle are congruent, and this would be the hypotenuse of your right triangle, okay? So we have an angle and a hypotenuse, and it's a right triangle, so we can use by the HA theory, the hypotenuse angle, okay, they are congruent. Okay, triangle RSQ is congruent to triangle TSQ. Then RQ is congruent to QT by the CPCTC. So we're going from a congruent triangle to a congruent piece of that triangle. That is why this is the CPCTC. Okay. So remember, CPCTC is corresponding parts of congruent triangles. Congruent triangles are congruent. Because we are going from this triangle is congruent to that triangle, then the piece of one triangle is congruent to a piece of the other triangle, because the whole triangle, part of the triangle, CPCTC. Okay? So it says, find the x-coordinate of t. Oh, hey, that's the one thing we're missing. So because the x-coordinate of r is negative 2a, the x-coordinate of t must be, goes in the same distance in the other direction, so it's not negative 2a, it's positive 2a. All right. So lots of conceptual ideas with this one, which is why I split it up into 2 days. Okay, you do have an assignment with these two, so get that done. Good luck.